Here he is. All right,
Thank
Mo.
you. Thanks very much for the introduction.
You're very welcome.
Cheers. Yes, I'm Mo. I'm working for Dyson in the UK. I'm coming from Bristol, and today I'm going to take you a little bit on a different journey. We're going to look at the product and not so much on the ML algorithms. I'm sure you enjoyed a lot of it this morning. We're going to look at the actual physical products, and we're going to see the challenges we are facing. To understand that a little bit more, I'm going to have to explain the dynamics of how it works in our company. So we normally have, so my team is called New Product Innovation Software Team. So we are responsible for building first version of the prototypes for all the range of the products that we have. And it has a lot of challenges because we have diverse range of products. It starts from air purifiers, vacuum cleaners that you definitely know them, lights. We have hair care products, hair dryers and air wraps and hair straighteners. And we have products, and we also have products that you might not know about them because they're going to come out in next 3 to 5 years, and we are also responsible for them. I'm going to actually show you one of the exciting products that you're going to be able to buy in near future. So the challenge we are facing here is that we have different teams working on all these products. We have starting from research team that they're responsible for actually preparing the ideas, technologies and all that, and we have designers, innovative people, creative people. They come up with the shapes and designs and all the new creative ideas, and then we have engineers. They're responsible to take those designs, put into actual tangible prototypes, build them, and then we have manufacturing teams, take those first early stage prototypes that might not be robust or scalable. They'll take them, build them again from scratch to make them scalable products, robust and reliable. And then we have manufacturing lines, basically, that is at the end responsible for mass production. Then we have other like commercial teams and sales and all that. And it is difficult because all these people have to work on the same product and they need to keep in touch with each other. But at the same time, you want to iterate fast and you want to build products very quickly. So just to give you a little bit more context, I'm going to talk about one of the examples of the new products we worked on. Has anyone heard about Dyson Zone? Exciting. So I'm going to surprise you today. This is one of our new products that got launched this year. It's air purifying headphone that is a headphone, it's a high quality headphone that has all the noise cancellation and all that, but also it has air purification on your earbuds that purifies the air and lets you breathe the clean air. This might not be a problem for European cities, but it's a very, very huge challenge for large mega cities like Beijing or Shanghai and all that. So this is a product that has a niche challenge and a niche market to address, basically. So this is going to be an example that I'm going to be able to explain what we do using this example. So there's like another layer of a story I'm going to tell you. So the challenge we are facing for this, creative teams are going to work on this early stage. They don't know how it is going to look like. This is like 3 years back, probably, when we started working on this. They have all these crazy ideas about how this is going to look like. And then at the same time, you have software teams. They have to start coding on it. It has lots of sensors on it. You need to actually write software, and it is not Python, unfortunately, to write in 2 lines code. And it is C, it's hardcore stuff. You have to actually, spend, I don't know, thousands of lines just to print something or read the sensor data. So it takes time, unfortunately. And Then you have test teams. They need to be prepared for testing once the product is ready. You have hardware in the loop test, you have software test, and you have app teams. They design the app interface. You're going to have an app that shows you all the experience you're going through. You have air quality sensors, how much you're breathing, and also your audio experience of like a noise cancellation and all that. And you have cloud teams. They're responsible for getting all that data to the cloud and analyzing that and giving you the best experience. So all these people are working together, but then they're on global teams and they're not at the same place. We have teams in the UK, Southeast Asia, and China, and they're all working on the same product, and the product is physical, is not just the software that you know, put it on the GitHub. So the challenge is product is not ready yet, and it is changing, the concept is changing, and they want to all work on the same product as of the latest changes. So how do they do that? Our team comes in to build the prototype of the product, the very first prototypes of the product that might not look like the product, but it has to behave exactly as the latest stage of all these different teams. It must have like behavior teams and UX UI designs will say, oh, if you dip the visor, you have a visor here, you're breathing. If you dip it, the product should automatically reduce the speed, fan speeds on that. Or you wouldn't have, I don't know, if you're running, this experience should happen. All these like human-machine interaction bits and bobs needs to be coded into the product. But then the app designers should have the same thing because they're designing the app that shows you, oh, notification, you're running, your air quality is high and low. And it's like really intertwined to each other. So we are building early stage prototypes to have all these things into it, but also quick to change and easy to build. So we give one of these prototypes to each of these teams wherever they want to be, and they can actually, using that, they can do whatever they want without having to wait for the manufacturing process to be ready and finished. So this is in a nutshell what I'm going to actually talk about. And at the end of the talk, I'm going to give you a couple of takeaways. So if you wanted to, in your company, have a way of prototyping things quickly and seeing the commonalities of the things you're building and putting them in a reusable way and blocks, hopefully that's going to be the takeaway from this talk. So, yeah, this is as you can see, the physical form of the device that is changing. And you can imagine how much the software is changing. So creative teams come up with an idea. We want to build air purifying headphones. They don't know how it is going to look like. They start with the snorkels, doesn't work, do lots of tests, human trials. We have like labs and all that, noise tests, filtration tests and all that. And things doesn't work, obviously, and they have to change it and iterate it. But at the same time, software teams started working on that shape. Behavior teams started working on that shape and all that. So things change and people change, and change is not a bad thing. Software engineers hate it. They want to have a clear requirements when they say, oh, if you get this sensor value, if this, then that. You know, a lot of you are the software, and they normally hate changes. So, but we want to embrace the change, because if you want to be truly innovative, you have to embrace the change and give that flexibility to your designers to be able to have really groundbreaking products. And basically, I'm going to tell you how we solved this problem for our products. We started by seeing all these requests coming to us and all these product categories. We started to prototype them, and we saw there is a certain pattern in between all of them. Either it is a vacuum cleaner, or it's a hairdryer, or a robot, or whatever. They all have a common features in them. So as we built more and more, we realized we have to actually have some building blocks that we can reuse. And when the designers are telling us, can you build this thing for us? Can you, for example, build this flying chair? We have this crazy idea. Can you build it for us? We want to see how it works. We will be like, okay, we have this on the shelf ready, this part, that part, and we put it together in a very quick, short period of time. Come and show them, this is a flying chair. And they were like, no, this is not what we wanted. Forget about that. So a lot of things happen like that. We have like a massive list of products we want to build, but then as you go through the pipeline, they got reduced, and then at the end you have really high quality, tested and bulletproof products coming out of the pipeline. So common features of these prototypes are an embedded device normally, and a cloud part and an app part. You always have these, and everything is becoming connected right now. Whatever new products we are releasing, we aim to have it a connected product. So it normally has a Bluetooth connection to an app. It normally has a Wi-Fi connection to the cloud. An app obviously has a Wi-Fi connection. So the common features is you normally want to be able to update these over the air. Like when you change the software, you want to, wherever this box of things are on your desk or whatever, you want to update them. Whether it is in China, Southeast Asia, you want to be able to push the latest software to them. You want to remote debug them when they are in the test scenario, something doesn't work. Our team wants to check what went wrong. And easy to change, easy to add peripherals. If you want to have new sensor, you want to, some of the product teams come and say, oh, can we have like this new, I don't know, gas sensor, whatever. Can you put it in there? Should be able to do that quickly, and should be able to support all range of our products. So for that, it's sorry, not very readable, but I know what I've written there. So normally we have a product basically prototyping building blocks that consists of lots of building blocks that are basically Docker containerized. And they talk to each other using MQTTs, and we use Linux platform to prototype these. It could be Raspberry Pi, it could be any other Linux, depending on the product we are using and the processing power we have. So we have Wi-Fi communication blocks that's basically responsible for taking information, talk to the cloud, send information, receive back, and all that. We have a BLE building block that is responsible to talk to your app. It is the same. It's going to be the same for all the products. You just need to change the configuration. So we just build a building block. We give it to all our prototypes. And it has a fleet management. It's really important. Like we have hundreds of these prototypes in all our teams in all different countries, and we want to manage them, how many of them online, how many is using the latest version, how many is using a specific version, and what is the memory usage of that and all that. This is called fleet management. So we have that. We have logging. We want to record if something went wrong, if something failed and all that, because one of the exciting things we are doing is actually we are using production code as well in here. So as production teams are developing the actual, let's say, C code or embedded code for the final product, we take that, we take a copy of that code, we push it in these, and as the testing teams are testing it, they also test the final product as well alongside on, let's say, unconsciously, we are achieving that target as well. So if something failed, we want to tell them, fix the bug and send it back. So, and we have a future roadmap for each of these building blocks, depending on the future roadmap of our product categories. We have like this Wi-Fi, let's say, building block needs to be able to support next category of next generation of Wi-Fi 6 or whatever. It's like, for example, this is a roadmap for our products. So let's take it back to the Dyson zone. So that platform prototyping, we have it. Now we want to address the challenge of Dyson zone. So as I said, imagine global teams, coronavirus, no one can work in the office, you don't have enough products to send to people's home. What you want to do, they come and tell us, can you help us? Can your team help us to basically unblock this development process? This is the first product we are building. It's the first wearable product that has a classic audio, which is like you play music, and also BLE, which is low energy, Bluetooth to send the data. And that's all a lot of like challenge it has. Like when you connect your phone, you want to, let's say, link these two connections at the same time. And app teams, they don't have anything to do that. The product is not ready. So we built this basic emulator, I call it, which is the core of this challenge. We built this basic emulator that can do it for them. And we give it to them, and it's like, okay, using this, you can pretend that you have the final product, and start using it and test your app with it or your cloud platform with it. And then we were like, okay, we have this, why not we add more features to it? We add the air quality sensor. We don't have a sensor yet, but we can fake the data, right? Or fake the realistic data, put some realistic data in there, even though there is no sensor. We can emulate the behaviors, all those UI, UX interactions. We can emulate it, fake it, and put it in that box that we are building, give it to people. And all the other things, we can just test it there. So to address that challenge, we built our product emulator. The shape doesn't matter. We decided to go with touchscreen, but it doesn't matter for your product. If you don't need that interaction, you don't have to have a touchscreen. The core idea is to build a quick version of what you want to build at the end, early on, so you can test it and everyone else knows what they're working on. So everyone is on the same page. So this product supports a lot of things right now. It has onboarding journey, so you can connect your app to it and it will feel like you're connecting to your headphones. You will get all the sensor information and you can actually change the values and see, oh, what if the temperature is too hot? How is it going to look like in my app? What if the battery is very low? So I change the battery low and I see, oh, I get an alert, my headphone is shutting down. So all these user interactions, they can test it. And over-the-air update, so normally when you want to update your headphones, the update goes from the app to your headphone over the BLE, and it's a lot of information. It's a very high throughput link, and BLE is not very, is not very robust. It's not like Wi-Fi. It doesn't have a high throughput. So you needed to actually figure out how to send the packages there. So we built that into the product so they can actually send the update from the app to the product. And faults at the same time. Fault is really important. When something is breaking, your sensor is not working, your motor is not working, you want to be able to actually understand that fault and send it to the cloud and then back to the dashboard so the monitoring teams could see, oh, how many products are failing actually. And the state machine and much more. So this is, in a nutshell, is what we built. And it had a huge success story, and the product teams could actually start developing their ideas and the apps and the cloud side. Another example of the prototyping platform that we managed to use is this is again a new thing. This is not for the general purpose. It's not available to buy. It's more of a research platform. This is an air quality monitoring backpack. So it's a backpack that has a really accurate sensors on it. You can walk with it everywhere you want, and it will map your journey on the map with the air quality exposure that you had. This is it's a really important challenge because air quality tends to be ignored, and it has a long-lasting damage in human life. So we want to first understand what is the level of our exposure. So we have hundreds of these backpacks now built, all from scratch in our team, and we are sending them to the different countries and people can wear them and go out and see their exposure levels to the air quality. So we were able to build this so quickly because of all the building blocks that I explained to you. We had them ready. You just put them together, make them more robust, and you have a product and platform. As you can see, it has an app that can show you those rings are your daily exposure with the colors. It will tell you if it was green or red or whatever. That's like the amount of bad air quality you got. And also on the map, you can see color-coded journey of your air quality. So that's it. And as key takeaways, I wanted you to basically take away from this session when to use product emulator. That's the key thing. Product emulators could be used whenever you think your final product is going to take time to be ready. So build an emulator, unblock all the teams. How to create your own prototyping platform. It's a really important takeaway as well. Whenever you see commonalities between all the projects you're doing, try to take the similar bits and make it more robust and reusable so you can save time in the next project. And always remember to design with the change in mind. Don't try to avoid the change. Change is good. You just need to be ready for it. And that's it. If you have any questions. Yes?
Great, thanks, Mo. What? Oh,
you're welcome. Yeah, there's a question. Yeah.
So actually, it seems like did you guys, I think you already did, think about like adding an Oculus to your headset because it's getting the snorkel, it's getting everything. It seems to me like you're gonna end up with a helmet. It's gonna be the Dyson helmet with everything built in, air purification, headset, VR, AR, and everything. So, are you guys prototyping that?
Unfortunately, I can't share a lot of details. I already struggled to get approval from our IP and PR teams to be able to talk this much. As you know, it's like the new products are always challenging. But you're right that the core thing is to be able to add more as you go forward, depending on the test results you're getting from your. Yeah, it's a really good question. Yeah, thank you. Any other questions? Yes. Yeah. Most inefficient way? Do you mean because of the changes?
Because of the money that you spend on prototyping. Like, it sounds like before thinking it through, you just spend the money then.
It's not like we don't think through it. We have a, I don't know if you heard, our friend is asking, how can you make this process better? Seems like you are wasting a lot of money in prototyping all these different products that are not even getting it to the end of the pipeline. That is unfortunately the game we have here, because if you want to really produce innovative products and the new thing that you never had it before, you never know what's going to happen. So you have to actually risk it. And that's one of our models. We take the risk, we start new challenges, we take them to the end, and we realize, well, that wasn't the best decision. Failing fast is better than basically spending lots of time and thinking about it. And at the end, when you don't have a tangible outcome, your mind can actually take it that far. You can't actually, understand what is going to be the human interaction and the user interaction with that. So, yeah, I understand your concern with that. Yes? Yes, that's a good. Yeah, we have some periods of time that we call innovation period, and we all stop working on our actual day-to-day works and developments, and we start developing all these crazy, quick things and ideas. And that's actually another way, yes, we are doing that. And some of those, they end up to be added to the final products as well. Like some people and say, oh, we saw this new cool, let's say, virtual reality thing, and we just quickly prototypes it on our app. We show it to our senior product owners, and they like it, and they're like, okay, put it into the feature list for the next release. Yeah. Yes, that's a very good, really good question. So you're asking, we have all these features, why not we leave the APIs open? So for development or for hobbyists or for whatever reason, you can actually send the commands to the devices. It's not difficult for us to do it. The main concern is the security. So our security of the customer's data is the most important thing. We want to have trust in our company. So that is one challenge. The other thing is we are already working on it. So we're working with, as you know, one of the challenges in home product is that every company has its own ecosystem. You buy something, you need to install the app, you need to connect it with like the whatever hub they have, and they can talk to the other products. So we are actually part of larger consortium that is combined with all the companies. We're all working together to come up with one solution that fits all, and everyone will have a standard to actually adhere to that. And hopefully in a few years you will see you wouldn't need to have like 10,000 different communication methods, and everyone will use one. Hopefully, if you can get all these companies to agree and be friends with each other. Yes, good question. Thank you. Okay, thanks very much for your time. Really enjoyed it. Thanks very much for Codiax, and hope you enjoy the rest of your day. Thank you.
All right, round of applause for Moe. Very nice.
Thank you.